The fundamental problem I have today with all of these large language models and what we call AI is that AI doesn't know how to learn. You have to retrain it. Well, now you have to retrain it. You spend millions and hundreds of millions, God knows how much money. We got to build models that can learn, that can observe, that can see things, that can understand things. And that's really how I think the real world stuff can actually come in.
You've seen so many different ways, you've met different people. What is a story which has stuck with you from a motivation perspective?
Today, access to capital is so easy that people blow it very, very quickly. They don't value the money that an investor puts into a company. Young startup founders say, oh yeah, we raised $50 million or $15 million. Oh shit, it didn't work. Okay, $15 million has gone down the drain. There's no feeling of, oh my God, I blew somebody's $15 million. But if you value money, spend it properly, and spend it wisely, success does happen.
So Ash, welcome to the podcast.
Thank you.
So for folks who don't know Ashfaq Munshi, he's had a prolific career. He did his undergrad at Harvard, then went to Brown, and then Stanford. He's worked on multiple companies, had successful exits worth hundreds of millions of dollars, been the CTO of Yahoo. And I was fortunate enough to be a co-founder with him for a very small exit called company called Crypto, which ended up at Snowflake. So Ash, very excited to have you here and chat about your story, chat about GPUs, optimization, China, US, and a lot of these things.
You want to pick an old man's brain?
Yeah. No, I'm very excited. I think the type of stories you have and the things you've seen from the .com era, pre-.com era, mobile wave, AI, cloud, all of those things, I think be very helpful for our audience to understand. But before I get into technology, I think one thing which really stood out for me when I met you and started learning about your journey and started learning from you was you were 18, you were studying at Harvard, and you got married. And you had a kid, I think in your second year or first year, and you were studying in school, do a night shift as a guard. And you told me that story as hey, that was just pretty normal. And when I look at today's tech culture, especially, the SF Valley culture, people are like, hey man, we got to hustle, we got to build companies, forget about relationships, forget about, even getting married. Kids are a far thought for folks. Just want to get your perspective. How are you thinking about that?
Yeah, so I did get married when I was 19. I just turned 19. We didn't have a kid quite that quickly, but yeah, I was in my early 20s when we had our first child. But I have to tell you, it was probably one of the smartest decisions I ever made. And the reason is because it gave me stability and something that anchored me, which was really, really helpful for me. And I've always been very much of a family person. I always solved for family first, and then everything else sort of came second. Give you some examples. When I was at Silicon Graphics, I was probably the poster child of the company for work-life balance, right? I went home at a certain time every day. I worked my ass off, but it was very clear that there were certain boundaries. And then I would be home for dinner. I'd be home to spend time with my kids. And, even when I had to travel, I'd take red eyes so I could make sure I could put my kids to bed before I went. I made sure that my jobs were such that I never had to commute too much, so I wouldn't miss opportunities with them. And I tried very hard not to miss any of their events. That was extremely important to me. And for me, the legacy that I leave behind is not the money that I make. It's not the companies that I build. It's the people that I touch. And the very first set of people that I touch is my family. That legacy is far more important to me than anything else, because realistically, even if you're massively wealthy, people, you're just a check. I mean, it's the people who interact with you, the people who love you, the people who interact with you and understand something, that you teach something. That's the lasting value. And the reality of it is, after 2 or 3 generations, that value disappears. So your value on this earth is very limited. Might as well make it interesting. Think about what a lot of people today, young people do. Hey, they don't want to buy stuff. They want to do experiences. What are experiences? Memories. Memories that I do with my family, memories that I leave behind are the memories that are the most important things. Those are the things of durable value. If I teach you something and you turn around and do something with it, that's extraordinarily valuable. right? That to me is far more important than me giving you money for your startup. Does that make sense?
That 100% makes sense, right? Like I think especially the centering point and like the memories and the experiences and really having the meaningful impact. So what's your perspective like today? There are a lot of memes or there's a lot of tweets about like the 996 culture, like in China, and especially that coming to Silicon Valley. You have been in the Valley for almost 35 years.
Long time.
Yeah, long time. So what's your perspective on that? Like what advice would you give young founders, especially in their 20s, early 30s?
So, I work a lot, but I love what I do. So it's not work to me. So, do I count it as 996? Do I work as hard? Probably. But what I do is I try to interleave that with time for my family, with time that I take out to be able to go do things. But because I love what I do, it doesn't ever feel like work. And my family doesn't see me like grinding at something and coming back all tense and all that stuff. They see me enjoying what I'm doing. And so I'm not bringing back, a huge thing on my back saying, "Oh my God, today was oppressive," or any of that kind of stuff. So my biggest advice would be work as hard as you need to, but enjoy what you do. If you enjoy what you do, the rest of the people around you will see it. They will understand your enjoyment, and then you will then turn around, and the time that you spend with them will become quality time because you're enjoying it. You're not under a whip. That's the most important thing here. Enjoy it, and then it works. Look, I still pull all-nighters, right? I still wind up working. I mean, there are days when I start my day at 5 in the morning and end at 9 or 10 o'clock at night. That's not unusual for me. But do I think about it in terms of 996 culture and I have to go do this? No. The way I look at it is a bunch of things I need to get done. Some of them have a time bound, and I want to go do that. A lot of my time is not just spent working, but it's spent learning, right? I spend a lot of time reading and learning. And learning comes in two things. One is through reading and finding, and then the second one is talking to smart people that can actually teach me things, that can actually give me a different perspective on the set of things that I'm doing. So what happens is it becomes social as much as it is a learning thing, right? It's like I go to something, I go meet somebody, I'm learning and I'm having a good time learning. I enjoy their company. And at the same time, I have an extremely high bandwidth conversation from which I'm absorbing a ton of information that I can use to do everything else that I do.
That is great advice, and I think like a great way to start the podcast. Now to get into your other kind of perspective, right? Because you have spent time building in very massive technological ways, like pre-dot-com era, dot-com era, cloud, mobile, and now AI. And each technology has built on the previous one and made it easier for us to launch like all of these things. I think like AWS kind of made infrastructure as a service pretty easy. I obviously didn't see like what start was for before AWS, but AWS is much easier. And like now I'm building a company in the AI space. I'm like, holy shit, this is so much easier than building a company
And we
even
built the plumbing
a few
for you.
years ago. So from your perspective, what are some positive things you've seen across these technological ways which give you a lot of optimism for like the future?
The waves that I've been involved in have generally been driven by people with a vision, right? People who want to make a difference, people who want to invent, make something better. And that story hasn't changed, right? So, you think about Netscape came out of SGI, right? That was like, oh, we're inventing something new. At SGI, we actually in 1994, we did the first video on demand to 1,000 homes in Florida. I mean, think about that. 1994, we were doing streaming, right? It was like we were inventing all kinds of interesting things. It was the invention that drove us and got us to where we needed to go. Then we had the .com thing, obviously, because of the internet, and a bunch of things happened. Um, what was interesting is I personally like engineers inventing things because they're developing something brand new. The MBAs coming in doing things, their only thing they're interested in is making money and defining a market or anything else. And that's great. That's wonderful. And it needs to be done. but there's not this passion of changing the world from either a structural point of view or from some technological point of view or anything else. There's none of that passion. It's all about how fast can I grow this thing so I can get money and I can get my bank account to get bigger, right? I personally don't like that, right? I'm not interested in the bank account inventor or the bank account CEO. I'm interested in the person who's going to invent, who has a desire to go make a big difference and change the world, right? Fundamentally change the world. And right now we always talk about disruption, disruption, disruption. That's all wonderful. But it's a bunch of empty words, to be honest. Very few people can actually do real disruption, right? If you look at hardware, there's invention in hardware all the time. How often is it disruptive? Not very often. But what happens is every new bit of technology, something new happens, whether we go to fiber or, something else. Now, all of a sudden, networking can be done a lot faster. There's a fundamental change that happens. So there's lots of changes that happen in those pieces of infrastructure that nobody celebrates. But without those, none of the other things that people are doing could actually happen, right? Think about, the switches that are there, the power infrastructure there, the chips that are there. All of that stuff has to be present in order for us to do any of the AI stuff. And then all of the groundbreaking work that people have done to build systems, right? This is hard work. This is not something where you kind of put something together. Think about something like Kubernetes. Kubernetes took a long time. It was, started at Google under a different name, came out, became Kubernetes, and now runs a lot of infrastructure, right? That kind of invention takes time and that becomes pervasive. That's the stack that everybody builds on, right? You started off with the 8080 microprocessor, right? Then we went to the Pentium. Then we went to, sort of other things. And now we suddenly have discovered that NVIDIA chips are really good, right? They were nothing more than a graphics processor and a floating point unit that people used to think about. But now we moved our computation to that, and that becomes important. And that has become important. But that is built on a whole lot of infrastructure that was done. If you look at the NVIDIA chips, it's not just floating point, it's also a lot of networking. It's also a lot to do with memory. Getting all of the things actually working together is a non-trivial systems exercise, and you have lots of people that contribute to it. What happens is we get people who have these great visions to come out. Unfortunately, as I said, a bunch of them are MBA types and doesn't quite work. But then you have inventors. I mean, as much as I kind of, have some issues with Elon Musk, the guy is doing some pretty interesting stuff. I mean, reinventing how we do space. He didn't exactly invent Tesla, but okay, he took it and he took it somewhere, right? There's a bunch of things that he's doing which are inventions, and he's not doing it to make money. He's doing it because there's a vision that says, I want to be able to fundamentally change the world. And that's the kind of inventor that actually makes a difference in the long run. Everybody else is sort of incremental. And fundamentally, let's face it, 99% of us are going to be incremental. Right? Only the 1% are going to actually make fundamental changes. And those breakthroughs can occur in many different ways, whether I discover something fundamental in science or I wind up having some way of putting a system together that's different. I mean, think about what Steve Jobs did with the iPhone.
Absolutely.
And that fundamentally changed how all of us do things, right?
Yeah.
But it was the right time to pick think about the wherewithal it takes to say, I can take this technology for a screen. I can take this technology for a CPU. I can package it all together and I can deliver it first as the killer application was not that it was just a phone, but it also had GPS in it, so I could do mapping, right? And sure, I could do email and all the other things, but it just changed the way everything was done. There were only 4 basic applications at the beginning, right? But even those 4 were massive,
Yeah.
right?
People still use mobile
People.
GPS. Like,
That's
that's
exactly right. So all of these things are sort of fundamental changes that these people did. They had the vision to be able to do it. By the way, look at both of them. They didn't go after saying, I want to become the richest person. They basically said, I have a vision of how the world should be. I understand these technologies, even though I don't understand them necessarily at the deep down level, well enough to be able to integrate, and I can assemble the team to be able to do that. That's the other thing that's very important. Great builders can attract great people to build stuff for them, right? One of the things about, if you think about, with somebody who's leading a war, right? They can command the troops to walk into the worst possible situation, right? Essentially the equivalent of walking through a wall. But if there isn't a leader that says you can do it, I'm going to be there with you, and you can do it, nobody would even try. right? And so you need these leaders that can pull you to basically do something that doesn't come naturally, and then put the right set of team together where everybody plays off of each other and said, wow, oh, we could do that. Oh, I didn't realize we could do this. Here's a different way of doing it. And then all of a sudden you invent something that is really, really breakthrough. But you need a leader that pulls, assembles the team together and gets things going, right? One of the critical pieces of being an entrepreneur is assembling a great team, right? I don't care how good your idea is. If you have a second tier team, it'll never go anywhere, right? You know, the old thing about, you know, yeah, a B team with an A idea will screw up, right? An A team with a B idea will turn into an A idea and be successful. And that is absolutely true. It starts and ends with the people around you. End of story.
100%. No, I think you said few things, right? So I would love to double click on that. I think one thing you talk about the team, that I think 100% agree with you. You talked about like foundational building blocks which are contributing to our wave today. So a lot of people who are listening, they may not even understand like what Silicon Graphics did or what are some of the key fundamental building blocks. If you had to like in 2 minutes break down some of the key technologies or key foundations which are very critical for the AI wave today, what would those be?
So I think, you know, we could start at the sort of the lowest level of the architecture, right? We can start with chip technology. You know, back in the 80s and 90s, it was hard to get very high density chips. Then what wound up happening is we started getting to, you know, 2 micron kind of line widths. A line width is basically how small a wire I can actually go do. The moment I can do that, I can pack a lot of circuitry on there. The denser I can get, the more compute I can actually put on there. If I look at fundamentals of computer architecture, they were actually invented by IBM in the 1960s, right? So almost all the things that we think about with registers, that was actually done in the 1960s. IBM even had virtual machines in the 1970s. It was called VMCMS, right? Most people don't realize it, but they were the original inventors of that, right? So you have the chip architecture, which really, really matured, and the equipment that actually allowed you to make it. So you think about companies like Applied Materials that enabled people like Intel and TSMC to make these semiconductors. And then you have all the design tools that were sitting on top of that. All the design tools that allow you to say, okay, how do I actually put all of this stuff together? How do I actually go and make all that work? Those kind of things are really, really important. Then there was a language for actually being able to design, right? So you could actually now turn the design problem into a software problem where lots of people could be working on things to get together to be able to do that. So now you could build compute chips that were really good. At the same time, we had a whole bunch of stuff happening on the network side, right? It wasn't just that we send stuff over copper anymore. We could send it over fiber optics. We could compress it much better. We could do a hell of a lot faster job to be able to do it. Then we could interconnect these chips much, much faster. We could actually create racks that were interesting. But then we realized, hey, that generates a lot of heat and requires a lot of power. So we invented cool ways to be able to do that. And so all the physical infrastructure sort of got built up this way. Then as the physical infrastructure started getting built up, we created guys who put this network together around the world, right? So fiber was laid, the machines could communicate with one another. You have people like Akamai who could place things at the edges so that things happened to be much, much faster. Now this infrastructure gets built up around all of that. And then there was a software stack that came on top of that. Unix was probably really, really important in being able to do this. Unix kind of unified a lot of the disparity that was around in the world before that. And then you started now saying, okay, now I have a fundamental systems infrastructure I can go do. People started building applications. One of the first things was databases. And in fact, relational databases. IBM had databases before, but not relational ones. By the way, the other thing most people don't realize, IBM invented relational databases as well, right?
Wow.
So the
I actually
reality
didn't
is
know that.
that's absolutely true, right? IBM invented relational databases. They did not patent it. Oracle came along, took all of the stuff, re-implemented it, and created the market for relational databases, right? So then you have sort of storage mechanisms and all the things that you can go do for storage. Then you have distributed architectures. Then you build software layers on top of that take advantage of it and say, oh, I don't have to just use this one machine, right? I can now use virtual machines. That's where VMware came in. Big step ahead in being able to go virtualize all the resources that were there. Then we started doing massive scale distributed systems. All of that stuff built up. Then all the UI work that got done. right? Apple did a lot of the seminal work that actually was based on stuff that came out of Xerox PARC. So all of this stuff kind of comes together in very nice ways. So you have systems for people to now use their imagination and build
Like
applications.
package system, which can like now get
The
end
package
output.
comes together. And the reality is every time we make a big change in the packaging, some fundamental change can happen in what we can expose and what kind of application we can build, right?
That's a pretty key point, right? Like in this AI, generative AI wave, like we are seeing that, right? Like suddenly we have given models the capability to like just ask a question. And for a user, what we've exposed is like, hey, you can in natural language suddenly ask a model to like help you write code, or ask a model to generate an image, or like ask a model to like generate a song, which obviously before we models had some of these capabilities, but they were not exposed. One, also LLMs were just not at that level. So we suddenly had these two shifts. So from your perspective, what are some opportunities over the next 12 to 24, 36 months you see? Maybe two, three ideas, which we can, maybe we can, do something different here. Like when we spend 2 minutes talking each about these ideas for listeners who are thinking about like, hey, what can they build? Maybe they get some.
So I think one really cool thing, and it's a hard problem right now, is we have these models, right? These language models. What we really need is world models, right? How do we see and interact with the world appropriately, right? That's a very hard problem. How do we get a robot to actually put a hand around, solve a problem, to pick something up and move it, right? How does it feel when the things are there? All of that kind of stuff is probably the next decade, I think, of really, really interesting work, right? And the interesting part about that is, how do you collect the data for that? In language, we had it easy, right? We had all this data that was sitting in the machines,
Yeah,
right?
books.
For this, you have to simulate, you have to watch, you have to do all these other kinds of things. So it leads one to ask the question, how are you going to build these world models? Where's the data going to come from? A lot of people saying it's coming from simulation. Yes, there's lots of good simulation that we can do to be able to go do that. A lot of it is from watching real world things happen. And I'm sure we'll wind up doing that. But the fundamental problem I have today with all of these large language models and what we call AI is that AI doesn't know how to learn, right? The models don't know how to learn. If you think about, I have grandchildren, right? I see my little granddaughter going off and do something. She figures out how two things can be moved and problem solves, right? It's not like she was trained on massive amounts of data to be able to go do all this stuff.
Or had an
She's
RL
actually had a very
Python.
small life. She
Yeah.
hasn't had access to she's had very constrained stuff, but yet she can solve very complex problems. But every time she does it, she learns how to experiment. She learns how to learn from all of those things. She learns how to learn from the failure. Then we guide her to be able to go do that. Models don't do that. Models don't do that at all. Models, think about every time we want to do something new with the model, you have to retrain it. Well, now you have to retrain it. You spend millions and hundreds of millions, God knows how much money, to spend and say, okay, now it's going to get incrementally better. But it doesn't know how to learn. I think the core of this problem is we got to build models that can learn, that can observe, that can see things, that can understand things. And that's really how I think the real world stuff can actually come in, because they can learn by experimenting.
So which companies you think are focused on that, or like which labs, or
So
like which
the only
labs?
one that I've seen that actually has articulated that this is the kind of thing they want to do is actually Thinking Machines Labs, right? They just recently, I forget who it is at Thinking Machines Lab, did a TED talk recently that basically says, hey, we need to teach the systems how to learn. I don't, I don't see. I think Meta, if they got their virtual world stuff and all that stuff together with this, I think could be doing interesting.
Yeah. Yeah.
Niantic is doing interesting work.
Yeah, like I guess Niantic came out with the Pokemon Go. You
Yeah,
can find like,
yeah,
so that's some
yeah,
really
yeah, yeah,
interesting data on
yeah.
that. If I'm like in my 20s or early 30s, and I'm like, hey, I have like good math background, CS background. I'm like, hey, I want to work on a problem over the next 10, 15 years. I don't want to chase this AI hype. What should I do? Like, should I go like do a PhD, or like go try to join a company? Like, how would you approach that if someone
Uh,
wants to learn this and like really be
Look,
involved in this?
I'll go back to what I said about people, right? We're the smartest people you can find. If that's at a company, then you don't need the PhD to do it. You're getting a PhD level and incredible people in one place. In the old days, the only way to get that kind of expertise was to go to a university, which was world renowned, and you could go do stuff there. No longer is that true, right? You could go, I mean, honestly, you could go to MSR, or you could go to Google Brain, or you could go to OpenAI potentially, or some of these other guys, where you're surrounded by extremely smart people that are pushing all these boundaries and things of that sort. You don't necessarily need to get a degree to go do it. The advantage. So what does a PhD get you? The PhD is just a proof that it's a piece of paper that proves that you can do independent work, that you can generate your own independent idea that's deep enough for some, that says you have enough knowledge in one place that's deep enough that you can generate a good idea. That's not, but that notion is not restricted to a university. It could be anywhere. Right. I know some extremely smart people that actually never went to college, but have unbelievable deep understanding of stuff that would far exceed most professors that I can meet today. Right. But they learned it, they understood it, and they worked, and they were surrounded by incredible people to be able to make that happen.
That is great advice. So we talked about an infrastructure problem, or like a very deeply technical problem. What's like maybe an application level problem which you think is pretty interesting?
Look, everybody's working on code right now, so I think code is interesting. My experience with the various agents that are out there writing code, they still need a lot of work. There's a lot of guidance they need and things of that sort. They don't really know how to abstract properly. So I think building systems that can abstract and be able to really back off and abstract something and really understand sort of a conceptual of what's going on, that, by the way, applies in law. It applies in medicine. It applies in all these other things, right? Medicine is a little bit of an interesting sort of sequitur, non sequitur, if you will. In medicine, doctors learn how to pattern match, right? So the doctor is as good as the experience that they've had. In other words, the number of cases that they've seen. That's a classic example where I think the machine learning what we have today, where we just give it lots and lots of data, it's able to do really, really well. And so, you see, especially in imaging diagnostics and stuff like that, the machine learning models can often beat what the doctors can wind up doing, precisely because they just have more information that they've been trained on. They understand a larger corpus than the human does to be able to go, make that change happen. So they don't know, you don't need necessarily a lot of abstraction to go do it. The same thing is probably true in law and maybe even in accounting and things of that sort. And by the way, those are exactly the set of things that people are building sort of verticalized AI applications on today, because it's really a function of the right type of data, being able to make sure that the right constraints are set up, and you can actually get pretty damn good results out of that, right? I think for the next few years, the ideal thing for me, or I would see, is AIs assisting humans, right? So human in the loop, I think, is probably the most important thing that one can do over the next few years, because we have problems with hallucinations. We have problems with a whole bunch of other things of that sort. Human in the loop can actually solve a lot of those problems and accelerate how fast a human can work. So if you can now suddenly 10x the human, 10x the engineer, 10x whatever it is, now you could make a substantial difference in the number of cases you can see, the number of things you can go do, and your velocity increases, and your output increases, and as a result, you can actually contribute more positively. So I think taking the human experience and enhancing it using AI is the set of applications that I would work on, because the good news is the guardrails are the human being, right? They can see, oh, that's hallucination. I don't have to worry about that. If you try to make it all automatic, I think it's going to be problematic.
That's a great point, right? So like really think about applications where you can enhance a human experience. There's some human in the loop, and that kind of augmentation really helps you get a good outcome.
Correct. I mean, you look at the legal stuff. That's exactly what it is, right? You look at the other stuff that people are doing. That is really a really rich vein.
Yeah, 100%. I love, like there's so many legal AI stars. I'm actually surprised like there are that many. One thing I wanted to ask you is that you also like have worked as an exec in some large companies. You're a CTO at Yahoo. You built startups. One of the challenges a lot of folks have is sometimes deciding between a large company and startup. And one of the motivation for a startup is, hey, there's a lot of learning, there's fast moving things, there's less bureaucracy. While at a large company, you always get into processes, systems, which delay things. From your perspective, how does innovation get done at a large company, which is very similar to a startup, and which people may have a wrong conception about?
Well, so large companies actually can innovate and do innovate. Microsoft's a great example, right? Microsoft probably the best example, right? Think about the changes that have happened since Microsoft formed, I think 1979.
Yeah.
They've ridden every single one of those waves. They may not have been first out of the block, but they've done a really, really good job of taking that innovation, understanding it, creating a product set around it, innovating on that, and going really deep to understand that, and then having the account control to be able to go, sell it appropriately. That's a great example of a company where, they can innovate. They might not innovate as fast as a startup, but you don't have to, right? Because one of the things that a big company you can do is you can watch to see what other things are going on. You can see it's a self-selection process. Something is doing really well. You have one of two choices: imitate it or buy it, right? You always have that option. It will be the case that for those people who are itchy, you're not going to be happy at a big company. Just not. You're going to be happy at a small company. But I would argue that you need both experiences, right? What needs to happen is you can be itchy at work at a startup and learn a lot really fast. But then what happens is the rate at which you're learning doesn't have any structure around it. So you're sort of putting up the structure, you're doing everything. And sometimes what needs to happen is the raw data needs to actually be put into proper structure. So you can say, oh, this is how I should think about this. Oh, this is how I should think about this. There's a reason why big companies are successful, because they've structured things. That's the time you go to a big company. You go to a big company and you go learn, what's the structure? How do I think about this? Why did they create this infrastructure? Why did they do this? Spend time learning that. So now you learn that. Once you've learned that, you can now go back to a smaller company, apply that and your itchiness to go to the next thing. I would argue the best thing to do is ping pong between them, right? Ideally, ideally what happens is you go to one of these companies that's a quote unquote small company, but you're at a high enough level and the thing grows nicely. And now you can go set the infrastructure yourself, right? That's kind of the ideal scenario. But you need to understand why structure and discipline are really important, as opposed to let's get out there and shoot with both guns.
100%. I think like then there's a balance between chaos and discipline and structure,
Correct.
and
Correct.
large companies obviously have that. Otherwise, there'll be pretty big issue, like when you're doing quarterly earnings or things like that.
Correct. But you also asked the question is, how do large companies do this, right? So large companies are interesting. Sometimes large company says, here's a division. Go and do whatever the hell you want. You don't have to be part of the infrastructure. Go build, go do whatever the heck you want. It doesn't happen all the time. And in fact, in standard industries, I don't think it happens very often, but certainly in tech, it happens. Go build this thing out. Maybe because I acquired a startup and said, go run, do whatever you want, build your own sales force, do whatever the hell you need to do. I'm going to put some protection around you to be able to go make that happen. When you start seeing that, you start seeing velocity go up in terms of invention inside the company. But then you get duplication, right? These two divisions are doing all these 5 things that are underneath it. They're doing it differently, but they're now spending a ton of money doing it, right? So then what happens is management comes in and says, oh, we're spending too much money on this thing. Let's centralize a bunch of these things so we can squeeze efficiency out, right? So you run to be as dynamic as you possibly can be for market share. You squeeze efficiency out. You spend a little bit of time squeezing efficiency, and then you go back to the other model, right? The ideal is you just go back and forth. Now, the whole company doesn't necessarily work that way, but you always have some things that are going independently, some things that you're squeezing the stuff out of, and you're constantly cycling between these. Those are the biggest, most successful companies, in my opinion. Apple's a great example of that, right? Apple runs things very independently, right? You have to sign an NDA from one group to the other to be able to talk
Well,
to other people in order to do that. I'm serious. So what that means is you have your world, you're executing. Now only if somebody at a very senior level, right, like the exec team level decides, okay, I need infrastructure to be able to go do that, they'll make that call and they'll put that thing in place. But until then, you're running on your own, right? And literally, I mean, I know people at Apple who work at Apple who've signed NDAs with several different divisions because they all work together, and you can't say what this guy's working on and what the other guy's working on.
Apple's iPhone, like there's a secrecy even between like if people who are working on the same iPhone sometimes don't know like what the other team is like building around like some other hardware or like
So
software.
you look at that and go, how can that possibly work? It
Yeah,
works, right? There's a living
beautiful
example that it
floor.
actually works, right? So there are many ways to slice this thing. In the case of Apple and companies like that, where you're generating huge gross margins and things of that sort, efficiency is not the most important thing for you to do. Velocity is more important, right? But at some point, you're going to wind up squeezing efficiency. At some point. you're going to
So it's
wind up
that
with.
balance. So like
Yeah,
the companies
it
are trying,
balances over time.
so the best companies are trying to find that balance. And like,
Correct.
sometimes people who are itchy may not find like, hey, this company's, this balance is not working for us, we should leave. But at some point, you may find a company which is like, hey, this is a perfect balance of
Correct.
like giving me the chaos, but also like the structure which I need to
Correct.
succeed.
So that actually segues into something interesting, right? Which is companies that flip-flop between different ideas tend to fail. Companies that are very determined, that actually say, I want to go in this direction. This is the direction I'm going to go. And they stick with it. They just work and work and work at it, can be very successful. And I would argue that's probably a good thing for people as well, right? If you're really wanting to do something, really, really focus on it and do it. Love it and do it. If you don't love it, change, right?
Yeah.
I'm not the kind of person who sticks with the same thing, contrary to my own advice. I like exploring because I want to learn lots of different technologies, and so that's what my career has been. But I have plenty of friends who focus in one area. They become very dedicated and go and pursue things. In my case, I'm very focused on technology. That's my dedication, right? So it's a different kind of dedication, but I am dedicated on being a technologist and being able to go do it, which is why I constantly keep up with everything that's going on.
That's a great
It's
point.
really easy for somebody to get to my age and say, well, I don't understand the new stuff, right? Well, it's not because we've gotten old and gray and our brains don't work. It's because you become lazy, right?
Yeah. Got to
So
read
if you've got
and
a
keep reading.
drive, right? I've got a drive to go learn. I read papers. I go talk to people. I talk to young people. I talk to old people. I try to synthesize all of this stuff together. And honestly, it keeps me young. It keeps me excited and keeps me going.
No, I think that is like super important, right? Like the key learning piece. So maybe like this is a good segue in like, like what you're working on right now at Pepperdata, which is your primary kind of focus beside other interesting things you're working on. So I was looking at Pepperdata's website. Like what is pretty interesting is it said like, hey, dynamic Kubernetes optimization save 75%. And as I don't know a lot about Kubernetes, and I was like, okay, what does this mean? Most probably like, hey, there's some cost savings involved. Maybe Kubernetes has some fluctuating workloads and you guys are optimizing them. But I just want to hear from you, like, as a domain expert, like what does this mean? If I'm a non-technical user, how would you explain that to me? And if I'm a technical user, how would you explain this to me?
So let me tie this back a little bit to my journey. So I've always been very mathematically inclined, right? Hard math problems are something I love. In my spare time, I solve Olympiad problems. Call me crazy, but I solve Olympiad problems. It's fun for me. In particular, there's one area of math that I really like. I love optimization, right? Different kinds of optimization, but I love convex optimization. This is an area that I really understand really, really well. But anything that's got a optimization thing, I'm like, okay, sign me up for this thing, right? Because we're gonna figure out a way to take something hard, squeeze something out of it, and then get something much better. I love that. That absolutely motivates me. So at Pepperdata, it's the same thing. And by the way, I've seen this story in computer science in general. So in computer science, what happens is whenever somebody's developing something and they're needing resources, whether it's compute, whether it's IO, or it's memory or GPU or whatever it is, they have an idea of how much they think they need. They kind of size things to the maximum. But what happens, like every other resource on the planet, you size it for the maximum, but what happens is you get fluctuations, right? So at some point I may use the maximum, but a lot of the time I may not be using the maximum. So all of a sudden there's this capacity that is sitting there wasted, right? And so the idea is, can you somehow put a useful work in the capacity that's wasted? So I might be using something where the fluctuation is like this. Then when I'm dipping, is there somebody else that can come in and use that resource? And as a result, that resource is now used much more, right? So if I think about at any given point in time, I want the CPU to be running at 95%. I want memory to be running very high, right? Because what I've done is it's not sitting there empty. I'm not waiting for the guy to finish to be able to go do that. I'm actually using that downtime to be able to schedule something new. That's the fundamental thesis behind Pepperdata, right? You've got resources that are utilized that actually fluctuate with time. What we do is we realize, look, there's a gap here. That gap can be utilized efficiently, and we can actually put more workload on there. And the nice thing about what we do at Pepperdata is we don't touch the rest of the system. We actually make sure that the rest of the system gets information from us that allows it to act the right way automatically, right? So we're not changing the scheduler. We're not changing anything that we're going on. But what we're doing is we're basically telling different things that orchestrate what's going on in the environment. Hey, you could do more. Go ahead and send more. There's more space available. There's more CPU available. Oh, there's a different kind, there's GPU available. So that what winds up happening is then whatever is doing the scheduling says, oh, okay, I'll go ahead and put that on there. The problem with that happens is that if too many things suddenly get put into that slot, and now you get failures. Right? So you have to now watch to see whether you're going to get to a failure state or not, and then say no more, preempt or slow things down. Right? That's basically what it is. So you have to set guardrails to say how bad can you wind up doing. So think about, kind of like the day, my days at Yahoo, right? Yahoo at that time had roughly 1 million machines. If we ran those machines at 80% efficiency, roughly speaking, 200,000 of those machines weren't really doing anything useful at any given point in time. So what you really want to do is run them at 95% efficiency. And we developed a bunch of techniques to be able to do that, one of which is called overallocation. That's part of what we do at Pepperdata. But it's basically, the idea is, let's get that resource that is sitting there to basically higher efficiency to be able to go make that happen. Think about office space, right? We have office space. People only use it during the day. Realistically, if we were clever, we would actually fill that office at night also. Right? And now all of a sudden you get much more result out of that, right? So that's the point. There's a resource that's sitting there. Why not use it for something else, right? Be clever and use it for something else.
I love your explanations. So one follow question there is, right, like, so in Kubernetes, this makes a lot of sense. In today's era, you obviously have this AI wave, and obviously Kubernetes are relevant for that as well, but GPUs are super relevant, and people are buying left, right, center GPUs for like pre-training, inference, etc. Are you guys working in that space as well? Because I assume optimization there is super critical.
So we absolutely are. The first thing that our customers have told us is, you ask a developer what GPU they want. They'll give you the most expensive one that they can get their hand on. Nobody's going to say, I want the one that's 2 generations back. Nobody's going to say that, right? The other thing is they're going to say, I need it at 3:00 in the afternoon, right? That's the time I need it. So they don't think about where everything else sits and how everything else. So the first thing that we do is we kind of make it clear what's the demand and what's the pent up demand that is available for these things. What's pending to be able to go do. So now you can immediately identify that, oh, you know what? Everybody wants to use Blackwell at 3 p.m, right? No, we don't have enough Blackwell chips to be able to go do that. So now you can go and have a conversation with every user and say, hey, do you really need the Blackwells, or can you do with H100s? And instead of at 3:00 in the afternoon, can you run this at 2? Or maybe I can give you a Blackwell if you do it at 4 a.m, right? Those are the conversations you can start having, where you can now take your supply, which is finite, and essentially move the demand around and size it so it sits in the right spot. So what you're doing is you're basically saying, I have finite resources. I'm going to allow those finite resources. I'm going to make everything available. I'll give you an analogy. Think about conference rooms. You have conference rooms with 20 chairs. You have conference rooms with a large desk. You have conference rooms with telecommunications capability, video capabilities, right? You have conference rooms with, shades that come down, or they don't have any, natural light or whatever. Now, all of a sudden, everybody wants to schedule these conferences. And everybody says, oh, I want one that's got, 20 chairs in it. It's got a large conference table. I want it at 3:00 in the afternoon. I want it in this building. And I want it to be so that it doesn't have any natural light in it, so I can have clarity of the video that I want to be able to get. Well, you're not going to get that, but you have other conference rooms that are available. The other conference room, you may trade off one of these things or the other. It's the same kind of problem, right? It's that resource that everybody says I need, but if you actually have the conversation, you can do this. So right now, we allow people to have that conversation. In the next generation, what we do in a few months, we'll do this automatically. So think about like conference room scheduling happening automatically. I understand what you've got. I understand what you need. I'll actually move it around in the right way to be able to make that happen. Right? So that's important. The interesting thing is the way we do that is we have this technology which we call fingerprinting. So we look at, in the Kubernetes language, right, what namespace this comes from, whether there are any metadata associated with it, what queues the thing is in, how is it named, all its past history. That gives us a really good understanding of what the best place is to put it, right? And so we basically use that information, create a fingerprint, and then basically say, hey, next time this guy's asking, this is really what they're going to need, and we'll put them in the right spot, right? That fingerprinting is something that we do. It turns out that that same fingerprinting can also be used for execution. So modern day GPUs can actually be sliced, right? So NVIDIA GPUs can be sliced, I think, in 8 ways or 9 ways. I can't remember. And what you can do is you can say, oh, give me a fractional GPU. Now, a fractional GPU may not be enough for what you need to do, but it may be. So what we do with Pepperdata is we basically say, we'll manage this pool of GPUs for you, but instead of thinking about them as full GPUs, they're going to be some full ones, some half ones, and some third ones. Right? We've sliced them in half, seven, and third. And now we're going to move your workload into these different buckets to be able to see. If we assign it to a third and it fails, we'll move it to the second half. If it fails in the second, we'll move it to the full. And now you've got the full execution that you need, right? But what it does is it allows more stuff to actually take place simultaneously, because not everybody needs the full GPU. Some can actually use the sliced GPUs, and as a result, you can actually create more utilization on the GPUs. At the end of the day, GPUs are hard to get. They're expensive. If you can increase utilization, that's a lot of money that's being saved.
100%. So the question I have is that, so a lot of companies are trying to do these optimization things. Like, what's unique about Pepperdata? Because when I Google, I'm like, hey, let's see, who else is in this space. So there seems like there's a list of 10 plus folks popped up.
No, so there are people doing different kinds of optimization. People doing for specific training, people doing for fine tuning, and all this. Ours is more generic. If you have any jobs that are basically started or using Ray on Kubernetes, we can basically do that for you without it all automatically. There's no no additional work that you have to do to be able to go do that. We're very, very unique in that capability. Very, very unique. And this fingerprinting technology is the key thing for us to be able to go make that happen.
My understanding is that obviously you cannot share some of your customer names, but a lot of Fortune 50 companies are utilizing you for core infrastructure today. So
yeah, I'd like to make that stronger. We have 2 of the Fortune 5.
Wow, okay.
It's not so bad.
That's crazy. That's pretty impressive. For a
we
small,
we have
not a small startup, but
for a tiny little pissant little company.
Yeah, mid-sized startup. You guys have 2 of the Fortune 5.
Okay, I still think we're a tiny little company, and yeah, I mean, we have most startups go for as VCs call it, logo velocity, right? They have tons of small companies signed up and all that kind of stuff with very little revenue associated with them. We actually are in a kind of an interesting position. We have a few very large customers, and they're all names you would recognize. There's not a single one that you would say, who's that? You know every single name, and all those names are household names on top of that. So it's not like you have to be in tech to understand it. You can pretty much understand what we got. So we're very fortunate from that regard. And by the way, tiny little team doing this, right? We are, 33 people or so.
How did you guys convince some of these logos to work with you? What was
it's called proving that the shit works. Look, at the end of the day,
basic 101.
At the end of the day, if it works, people will buy it, right? And the other thing is, the problems that we solve are most relevant to the people with the biggest workloads. And they're the ones who have the most economic pain. If you're a small startup, and you're spending money on this, it doesn't really matter. But if you're spending hundreds of millions of dollars on something, and I can save you 20% on that, that's pretty significant. But in order to be spending hundreds of millions of dollars, you can't be small, right? So by definition, our problem and our sweet spot is at the places that are the large ones. And therefore, those are the guys that we go sell. It was the case probably 3-4 years ago where we would do a POC and we would insist that you do the POC in production. And the customers would say, no way. Then we told them who our customers were. And we're like, oh, it's good enough for them. Okay, we'll try it. Now we do POCs, we do a POC on a non-production system just to prove we don't break anything. But to actually get data and actually do tuning and stuff like that, we insist that it's on production, and we don't have anybody that says no to us. No one.
That's amazing.
Right? That's credibility, right? And that's reference, right? It's really reference. We solve a real problem for really large businesses. They trust us. We support them properly. We're there. And, look, at the end of the day, selling is not just about the product. It's about the product, the service that you provide, the relationship that you do, how you understand what they do. And, the companies that we deal with are also very, very sophisticated. They want to be able to deal on the other side with people who are equally sophisticated and can understand what kinds of things they got. And we're very fortunate in having a team that actually understands distributed systems extraordinarily well. We understand how to do, deep, low-level infrastructure stuff extraordinarily well. And there aren't very many startups that can kind of match that.
I mean, clearly, like getting to the Fortune 5 is no small feat, especially if you're just a small startup. That's crazy. Uh, a segue I want to make here, like which is relevant to like your GPU, where again, in this AI kind of like capex spend, we're seeing massive data centers being built, and primarily they're just for GPUs are like the core thing which are being hosted. And one of the reason is that like the amount of demand for like inference and like training and all of these things are just off the charts. And I was kind of looking into like how these data centers are kind of built and what is some of like the core things which go into them. The biggest bottleneck seems to be energy, right? Like, because we can most probably solve for TSMC moving fast, some of the fabs moving faster, and Nvidia's revenue in 2025 close to $200 billion can fund most of these infrastructure spend which is needed just by itself, irrespective of like other hyperscalers. But when it comes to power, it's different, right? Like it's not like a power company cannot just start producing turbines in 6 months notice. Like they need stable revenue, they need like long-term perspectives, there's regulations involved. How do you think US will solve that? Because for a pretty long time, these data centers have used equipment and infrastructure built for the steel mills or the old automotive sector. And now we're getting to the threshold of that.
The other thing that goes along with power is heat, right? Is cooling, right? If you look at rack, the amount of heat put out by a single rack is going up in order of magnitude with almost every generation. So it's really, really hard to figure out how to go do that. Also, the physical
Even more
infrastructure.
power is needed for
Yeah, yeah,
future
exactly.
generations.
I mean, it depends on where you place them, whether you use convection or not, and things of that sort. I mean, there are people that say, "Oh, I'm going to build a data center in space," and because the problem is there's no convection in space. Yeah, how do you actually transport that heat away is a real problem. We need convection to be able to do that. So I don't quite believe in all that, but power and heat are a real problem. So in terms of heat, we're doing liquid cooling of different kinds, but the physical infrastructure has to keep up with that, right? The more heat we generate, the more liquid essentially that we have to pass by, right? Whatever conductive element there is, whether it's air or whatever else it is that you want to put on there. And with liquid, you got to then move more liquid per unit time or larger volumes of it. Then the infrastructure, the piping and all that stuff becomes heavier. It becomes heavier. So you have to size and build those data centers to think about volumes of water and all these other liquids that you're going to move 5 years from now or 10 years from now in order to get the infrastructure to last. Otherwise, you're going to build something that may work today, 4 years from now. You don't have enough density in the data center to keep doing something interesting. So there's all kinds of interesting things. It's not clear to me. We used to build data centers that say, okay, we're going to last 20 years. Right now, with the way things are going from heat and things of that sort, 5 years is kind of the time bound. So you can't pour a lot of concrete. You can't put a lot of money in there because you might have to rip it all out. So what's the design of the data center that needs to be done in order to be able to go do that? It's a very interesting problem. It's a very tough problem to solve. The second thing is just the amount of energy they get. So look, the fact of the matter is our grid fundamentally in the US is terrible. It's old. It needs to be upgraded. It's not clear that we have the wherewithal as a country to be able to go do that, which means that we're probably going to need power generation near the data centers. So whether it's a utility that's doing it or whatever, we're going to need to go and go do that. Now, what's interesting is if you go to a utility that's got sort of fixed output and you say, I'm going to suck out all your output, then, question is it going to raise? I mean, people are complaining like in Virginia, right? My utility bills have gone up because all these data centers are sucking up everything I've got. And my water bills have gone up because of the same thing. But it's interesting. If you add more capacity to this thing and you can essentially say the capacity is going to be there, what happens is over time, you can actually build enough capacity to lower everybody's cost. So this
Yeah.
spike in cost is a short-lived thing, and it should go away, provided that the utility builds enough infrastructure to be able to supply the demand that they need to be able to have. They can't continue to maintain that price delta. Over time, that has to go away. So to me, uh, small nuclear is probably a really good solution for being able to go do that. I think there are a number of people who are working on that, and we should really, really think about that. It's efficient. Now they can be designed in such a way that the risks of all the fallout stuff that everybody imagined, end of day kind of thing, can be dramatically curtailed, and they're small, they're contained, and things of that sort. There's all obviously a question about nuclear material and terrorism and all that, but I think we can put our arms around that. But that's probably the best. The second one is probably using renewable resources, but renewable resources that are available all the time are not necessarily local to you, right? And they may be far away. So we need transport and the grid to be able to go do that. If you look at China, China is building some of the largest solar farms on the planet, right? I think cumulatively they'd be larger than everybody else's solar farms combined. And they're putting the infrastructure in to get that electricity back to where it's needed. Places like Shanghai and Beijing and all these other places, and where they've got their data centers, they're moving that stuff, right? They're also investing in battery technology and stuff, because the thing that we need to be able to do is we need to store it, right? To be able to say, oh, you know what? During the day I generated it, during the night I can't generate it. I got that. There's also backup, right? Will we use natural gas? Probably. I'd like to hope that we're not going to use coal very much, but that may still be the case. But natural gas, oil are and coal are certainly possibilities to fill in that gap when there's demand and we don't have it. But I think if we could do a good job of generating it, being able to store it so we can use it offline, and generating it in a way that's friendly to the environment, then I think we can actually solve this problem. So good news is battery technology is going really, really well. We're making massive improvements in battery technology. As a result of that, the battery power that's generated elsewhere can be used and stored. But I still come back to one fundamental thing, right? We don't have a grid that we can go do this with. We need to upgrade the national grid to do it. Until then, you're going to get local generation. You'll get local mini grids that people will set up that allow all this stuff to happen. But energy will be generated many different ways. I think the best answer in the long run is going to be small nuclear.
No, I think battery tech obviously is a big bet as well, like with long say small nuclear. So that's really helpful. One kind of thing I wanted to chat with you about is because you work around the globe, you work for like multinational companies, in very different regions. So we obviously in this AI wave, there are two big countries, and to some extent, it has become like a wave of AGI, and countries are trying to approach, but really they're just China and US who is really competing for this, if you realistically think about it. And I was looking at a chart about the energy buildup over the last like 10 years, and China is just crushing it compared to everyone else. And then secondly, obviously their model companies are pretty active. They have some of the best refinery capabilities for rare metals, which go into a lot of these chips. And then one interesting thing is that every 3 years, chips gets depreciated and the race starts again from an infrastructure perspective. So maybe like China doesn't win in the short term, but long term, like they may have a
Well,
real
I
bet.
think they really thought this through, right? So let's go back to rare earth, right? Rare earth is fundamental for building the infrastructure, whether you're talking about chips or you're talking about
Yep.
batteries, right? So they have invested heavily in all of that stuff. They realize that's the building block for whatever it is that you wind up doing. It allows them to build solar cells cheaper, allows us to store the data, allows them to get, by the way, pollution out of the environment by having many, many car companies that are electric and going fully electric in that. They've done a really good job of being able to say, we're going to lock up that infrastructure. They've done a very, very good job of that. The other thing that I think the US had a lock on intellectual work, right? Through our university systems, our PhD programs, and all these other things. And so what we started seeing was more and more foreigners coming in to work on PhDs, from India and China, and staying here to be able to do the work that there is, because their universities weren't quite on par. They weren't quite there, right? The IITs are good, but they're not on par, so to speak. China was the same way. Tsinghua had the same problem. But now you look at those universities, they're amazing. They're producing very, very high quality graduates. And so even the people that are coming here, they're actually seriously thinking, do I stay here or do I go somewhere else? That lock that we had on sort of intellectual capital is becoming unlocked. We're losing that. And I think the more we rob the educational system of juice to be able to go do that, the worse it's going to become. That's number one. You look at the number of Chinese authors in all these different papers, it's massive. The number of Chinese authors or Chinese authored papers, just Chinese authored papers in AI, now exceeds those that come out of US. Right? So now you're now starting to see innovation actually come there. Then you look at DeepSeek. I mean, they're doing some clever things. You know the old story: "Mother is necessity is the mother of invention." Right? Okay, you starved them of chips. Well, they're going to do something clever with it, right? And they did. That's going to continue. So that lock that we had on intellectual capital isn't going to be there. They still don't have the fabs to be able to manufacture the chips and do all the other things that are there. But they've shown that they can. If you look at what they did with batteries, they didn't have anything. They just had the rare earth. They've now built battery fabs that are just unbelievable, right? They're going to do the same thing on the other side. Will they be able to go get that? I mean, there's no lock that we have on these things. Yes, we have tools, we have stuff that we can go do. But at the end of the day, they can acquire it, and if not, they'll build it. They might be slower, but eventually they're going to catch up, right? It's going to get good enough for them to be able to say, I don't need anything else from the outside to do it. The third thing that we have to understand is the US is much smaller than China in terms of its ability to produce talent, right? We have an outsized appetite for invention, but we don't have enough people to fuel it, right? So we rely very much on, people coming in from the outside to go do it. Well, guess what? China can actually rely on itself to do it. It doesn't necessarily need the rest of the world to go make that happen, right? It's got the horsepower to be able to make all that stuff happen. It can be self-sufficient in that thing. So the talent pool can be local, and it can be a vast talent pool compared to what we can create. We were relying on other people coming in. If we cut that off, well, that's gonna create a limit to what we can actually do here from an intellectual perspective. Right. So those are the kinds of things that are there. So they're set up the right intellectual thing that they can start competing, and they have started competing in very much. In the infrastructure side, they're competing very well. On the energy side, they're competing very well, both generation and storage. Right. The chip side, they're not there yet. But on the software side, I mean, you look at some of the innovations that have been great. I mean, the latest one that I can point to is, I think it was last week or the week before, DeepSeek put out a paper that basically says, hey, instead of doing text and sort of OCR kind of thing, if I just do convert text into an image, and instead of tokenizing using letters and words and things of that sort, text, I tokenize using vision, I can actually get tremendous compression. Tremendous, like 10x. That's phenomenally interesting, because if you can do that, you can now start thinking about, well, shit, I can potentially take the context window and increase this by a factor of 10 because I got tremendous compression on this thing, right? That's a very, very nice result, right? Just recent, they did it, right? Now, the very first result that they had that they talked about that made their model small and stuff like that. And, the accounting for it only cost a few $1 million is a little bit specious. And the technique that they use actually was invented at Google back in 2013. If I remember right, who's the guy at Google who actually talked about it? He's a senior scientist. I can't remember his name now. But they actually built it. They talked about this technology to be able to go do it. It just never got used. If you think about it, Google sat on a whole bunch of stuff for a long time. I mean, Transformers, right? All of the stuff that you go do essentially gets to one paper, right? Right? It's the one seminal paper that everybody talks about, right? The
attention. You're talking attention is all
the attention paper. Yeah. Attention is all you need, I think is what the paper's called. But there's a whole bunch of stuff there. The one thing I think where we do have a slightly better advantage than the Chinese, and I don't know for how long, is I think our systems thinking is better. We think about not just the software stuff, but we think about the whole stack. We have people that have been around and built a lot of things before. Because we've been ahead on these things, we can think all the way up and down that stack. And I think there's an advantage there. How long that advantage lasts, I don't know, because I know people in China that have now built systems. They're actually assembled systems. They're working on cooling them. They're building all this stuff. So they're learning also, and they're learning very fast. And they're also reading all the papers and talking to colleagues over here. So the rate at which they can absorb is very, very high. And it took us a while because we invented it. But the deep expertise that we have, they still can't replicate. But I think it's only a matter of time.
If you had to like think about like how can the US stay ahead in this curve, like what are some things are top of mind for you, maybe like a short 30-second 1 minute.
Well, I think first is just produce more smart people with advanced degrees, and keep them here. I think that is where the thing starts,
Your
right?
talent.
That talent to me is always the most important thing. The second is don't take funding away for doing basic research. It doesn't make sense. And by the way, what I just said applies to biotech as well, right?
Encourage curiosity. un, un
Curiosity, give them money, go ahead and actually go do this. It's exactly what the National Science Foundation did in the 50s, 60s, and 70s, right?
that
The
what
national
DoD did.
labs, all the programs that were there, all the research things that were there, the shot to the moon, all of these other kinds of things. These created fundamental technology things that actually made stuff happen, right? SpaceX wouldn't exist today if it weren't for all of the stuff that NASA did to launch Apollo,
Yep.
right? I mean, there was a lot of learning that come along with that, right? There's a lot of understanding. There's a lot of physics that came along with that, and we need to keep doing that. We need to keep basically saying we are the world's place where you go to invent and to discover. If you create that environment where people can invent and discover, and you give them the ability to go do that, if the invention and discovery happens here, the fundamental ones, the companies will happen here. The companies happen, the rest of the environment kind of picks up to be able to do it. At the same time, we do need people. So immigration is important.
Those are two solid points. So on that note, like, I would love to wrap up, but I definitely want to get a story from you, because you've seen like so many different ways. You met different people at different stage of their career, successful and failures. What is a story which has stuck with you from a motivation perspective, which gives you even inspiration and motivation today, which you may want to share with us to wrap this up?
I could take a commercial story, which is an interesting one. Um, and I may just sound old and a little bit, long in the tooth on this thing. Today, access to capital is so easy that people blow it very, very quickly. They don't value the money that an investor puts into a company. In the old days, every dollar made a difference, and it wasn't the land of free money the way we have it right now. You had to prove you had expertise. You had to have done a bunch of things. You came back and you looked at it. Maybe innovation was maybe a little bit slower, but at the same time, the value of the dollar made a difference. And the second thing was the fact that somebody gave you $1 wasn't like, well, if I don't succeed, doesn't matter. They have plenty of money, which is kind of the attitude now. Our attitude was somebody gave you $1. It's your job to return it and more. That's really part of your job. That's a responsibility. That's a moral obligation. That's lost today, right? I see, young startup founders say, oh yeah, we raised $50 million or $15 million. Oh shit, it didn't work. Okay, $15 million has gone down the drain. There's no feeling of, oh my God, I blew somebody's $15 million. Doesn't happen, which is really problematic to me. But if you value money, spend it properly and spend it wisely, success does happen. I'll give you a perfect example of it. There was a company called Veritas run by a man named Mark Leslie. Mark, I think, took on the company when it was like around $10 million or whatever. And for years, they barely made payroll. Years. Then all of a sudden, hit a hockey stick. Suddenly billions of dollars in revenue and all these other things. And then and in the Valley, people were writing about, look at this startup in the last 3 years, look how well they've done, everything else. And Mark would remind people, You forgot about the 6 years before that when we just basically were really, 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 hunkering down to be able to do it. It was the hunkering down, the belief in what they wanted to do, the reason why they wanted to do it. And everybody was there to say, yep, we share that vision. We'll go through the hard times. When they could have jumped to other companies as well, easily. At that time, think about Sun Microsystems and all the other things. But they stuck with it. They went there, they went through it, and they got it. And then they wound up getting escape velocity. And, the company was worth billions of dollars. Mark did really, really well personally, which is really an amazing thing for him because he stuck it out. He stuck it out. He watched every penny and things of that sort. And he told me two things. One is the guy at the end with the most money in his pocket always wins. Okay. And the second is money in a startup is more important than your mother. Right? These are really, really important things to remember. Long-term companies survive through hard times. Hard times are perfectly fine. Just because the guy next to you took an exponential path doesn't mean you're going to do it. But if you believe in what you do, if you believe that you've got real defensible technology and defensible things, I'm not saying, you go after a fool's errand and keep going after it. But if the market is telling you this is working and you can continue to stay alive, it sometimes takes time to be able to go do that, and it takes off. Another example of a company that does this is Arm. Arm's been around for a long, long time. And look at it. Now it's just taken off, right? Because it's like the right thing for
Right time.
everybody to start thinking about, right? Actually, NVIDIA was a graphics chip maker up until around 2012 or so, right? At that time, it was still a graphics chip maker. I mean, the valuation was sitting around $18-20 billion, right? It was doing a good business. It was all about, making games and video graphics and special effects and all these other things. And then all this stuff came along with machine learning, and all of a sudden it became more and more useful. And oh my God, this is exactly the right process to do it. So if you look at Jensen's journey on this, it was very patient. It was very deliberate. Did he have in mind when he founded the company that he was going to be at the forefront of AI? No, didn't even exist at that time. What it was I'm going to deliberately run a business. I'm going to own a market. I'm going to build good, solid technology, and I'm going to be smart enough to constantly be sniffing and saying, "Where's the next opportunity for me?" What he did was he did graphics and he went to self-driving, right? That was kind of the next thing that he wound up doing. And then all this AI wave hit and boom, the whole thing took off,
Yeah.
right? So the last 6 years has been where all the explosive growth has happened. Before that, so last 6 years is 2018, 2019. The company was formed in the late 1990s,
Yeah.
right?
I'm
There's a lot
I'm
of
pretty
work
sure
before that.
some of the early employees of NVIDIA, like, who may have left before 2015, 2016, like, shit. They missed like the
Yeah, so
massive.
so that's the one thing I got to tell you, right? You can never time these things. You never
Yeah.
know, right?
They never know.
Be happy with what you've got, and don't envy the guy with a little bit more money, because I can tell you one thing: money is not going to create the happiness that you have. Your definition of happiness changes as you get older,
100%.
right? And as you get older, just understand what your definition of happiness is. Happiness is not necessarily about having the most toys. Maybe at some point it is. We all go through these kinds of silly phases, right? But at the end of the day, I'm going to come back to what I said earlier, right? It's about the memories. It's about
Yeah.
the people. It's about the set of things that you leave behind. Because I got to tell you one thing, right? As I watch my elders going away, they ain't taking anything with them.
Yeah. 100%. It's like the memories and the experiences. I'm sure like the people who built the NVIDIA in the early days and who've seen its success love it as well, like the
Exactly.
impact.
They love the fact that they were associated with it, regardless of whether they made $100 million or not. Right. I was part of the team that did it. We built this thing. It was great. And even the guys who left during what I would call the game era of NVIDIA, they did some pretty cool shit. And they were very happy with what they did. They were on the top of the world. They were motivated. They did that. They made some money on it. That's awesome. If they held on to the stock, even better. But the reality of it is, it's the satisfaction of having done something substantial, and the experience and the set of people you worked with and the things that you were able to influence. Yes, it wasn't as big an influence as the AI thing is right now, but fundamentally changing the gaming experience wasn't a bad thing to do either, right? Because you suddenly changed a lot of cool stuff, right? That was also very cool, right? Suddenly being able to have a render farm that was actually pretty reasonable and inexpensive, and you didn't have to get these specialized pieces of equipment to do that. That was a big deal for film, right?
Yeah, yeah,
So,
100%.
these are all things that you could look back on and say, wow, that was great. Like I have friends who started TiVo. Who talks about TiVo anymore? But TiVo was fundamental in kind of creating the whole DVR thing and being able to do a bunch of things around that. So be satisfied with what you can do, because what happens is, 10 years from now, maybe 20 years from now, maybe the AI wave won't look as interesting anymore. Won't be the big thing. Maybe it'll be the next thing, right? Because we saw the internet. Oh my God. Oh yeah. Oh, I missed that opportunity. Then the mobile. Oh, I missed that opportunity. Oh, now you have the AI. Who knows what the next one's going to be? Maybe quantum is the next big thing that's going to happen, right? I think there's
There are
all
always opportunity. I think like that's
right.
one thing about like tech or generally like financial markets is like there's always interesting things happening as
Correct.
long as you're focused on core things.
Correct. Correct. You look at historically in the past, right? You look at companies that were built. You look at people were titans at that time. How many people actually remember them? Well, I mean, the guys from the '60s that were the billionaires in that time. Practically no one. The reality of it is, it's the thing that you invent that's good for now. Take stock in it, enjoy it, create happiness out of it, and spread the happiness to other people. How? By first of all, your attitude, and second, by teaching and mentoring. Pass it on. Pass it on, right? That's the most important thing you can do.
I think this is a great point to end the conversation. Ash, again, thank you so much for taking the time. This is a
My
terrific
pleasure.
conversation. I'm sure our listeners will enjoy as well. Thank you so much again for taking the time. And
Thanks, Hassan. I really appreciate the invitation.